So, what is science, really? I mean, it's a word we hear all the time, right? But have you ever really stopped to think about the incredible journey an idea takes? How does some little observation in a lab become the technology that, powers our everyday lives? Well, that's the exact path we're going to trace today.
Just think about the microwave in your kitchen. It feels so normal, so ordinary. But it's actually the final chapter in a really long story of scientific discovery. A story that starts with a simple question and ends up with a hot meal in like 2 minutes. So how does that even happen? Let's break it down.
All right, first things first, what are we even talking about when we use the word science?
At its very core, science is just knowledge about the natural world, and it's knowledge we get through careful observation. But here's the key. It's not just about collecting a bunch of facts. The real magic happens when that knowledge gets applied. That's the bridge that takes us from some abstract concept to a real-world tool, like that microwave, that completely changes how we live.
Okay, so if science is knowledge we gain by observing, who are the observers? And maybe more importantly, what's their method for turning plain old curiosity into an actual discovery?
You can forget the whole lab coat stereotype. At heart, a scientist is really just an explorer, someone who's driven by a relentless curiosity. But what separates them from you or me just wondering about something is their method, a really structured process of research and experimentation that's designed to separate what's true from what just seems true.
This right here, this is the engine of discovery, the scientific method. You start with an experiment to test out an idea. But, and this is so crucial, a single result means almost nothing. The key is repetition. Can you get that same result over and over and over again? That's what builds confidence. And then each confirmed result becomes the launching pad for brand new questions and new experiments. It's this continuous cycle of learning.
And this process, it works in some really unexpected ways. Take Wilhelm Röntgen. He wasn't even looking for X-rays. He was just methodically repeating his experiments with cathode rays, and he noticed something weird. It was right there, in that rigorous process of repetition, that he accidentally stumbled on a totally revolutionary discovery. It just goes to show you, sometimes the biggest breakthroughs aren't planned. They're earned through that disciplined work. So, as all this evidence builds up, an idea doesn't just stay an idea. It starts to climb what you can think of as a ladder of knowledge, and it gets more robust and more powerful with every single step.
Now, this is where we have to clear up a really common misconception. In everyday conversation, we use the word theory to mean like a hunch or a guess. In science, it's the complete opposite. A scientific theory is a powerful, super well-tested explanation that ties together a huge range of observations and results. It's the solid answer to the question, why is this happening?
You climb another rung on that ladder and you get to a scientific law. Now, a law doesn't even try to explain why something happens. Instead, it just describes a fundamental, consistent relationship in nature, a lot of times with the precision of a math equation. Its real power is in prediction. A law is so reliable that it lets us predict outcomes with just incredible accuracy.
So, to put it really simply, a theory is the explanation. It's the why. A law is the description. It's the what. So a theory of gravity explains why an apple falls, while the law of gravity describes exactly how fast it's going to fall. They're not in competition with each other. They're two different, totally essential tools for understanding the universe.
All right, so we've got these powerful theories and laws, but how do we get from that abstract knowledge in a textbook to the actual tangible technology that shapes our world every day? This is that final crucial step, technology. Technology is just science put to work. It's the bridge between understanding a principle, like, say, electromagnetic waves, and building a practical tool, like the microwave, that can cook your dinner. It's where knowledge finally becomes action.
And one of the most powerful tools we have for this is the model. Now, this could be a physical model that you can actually hold, but more and more, it's a super sophisticated computer simulation. By plugging in countless variables, scientists can test everything from what the weather will be like next month to how a new drug might work, all inside a virtual world. It's a way of safely exploring all the possibilities before you commit to building something in the real world.
So the next time you use your phone, or you turn on a light, or you heat up your dinner, just remember the journey it took to get there. It all started with a simple question in the mind of a curious explorer who followed this really rigorous path of observation and discovery. Our entire modern world is, quite literally, built on this beautiful, powerful process. The question is, what will you notice differently today?